All right, let's continue talking about semantics, defining semantics for programming languages. While we had a break, I took another look at the different specifications. So I found the official specification, right, for Ecmascript, which we know by other name, of course, is JavaScript. Why is it called Ecmascript? You know why? Well, because JavaScript is technically owned by Oracle. Oracle still technically owns JavaScript, right? There's a big petition that Oracle should give up this name. It's actually used by everybody, right?
And they also own the logo of JavaScript.
Yes, they own the logo, right? So you're not supposed to use it, the logo, right? You're not supposed to use JS logo, basically.
And they could copyright. Right?
Yeah, they could come on, they have more lawyers than programmers, right? So they could come after you, right? So, right, technically, right? So yeah, so technical specification is Ecmascript, actually, right? It just sounds pretty kind of horrible name, but yeah, okay. But yeah, but the thing is, but the good news is actually, well, good news is that it actually has it has official language specification. By comparison, we saw that C++, you have to compile your LaTeX, you can get it, right? It's also possible, but it's actually, it's even more dry than the JavaScript one, right? And sorry, I'm using Ecmascript as JavaScript, right? And also Python, right? So Python falls into the situation, it does not have official specification. Look at what it says. It is theirs attempts to be exact and complete. So attempts, it tries. Like you said, there's no try, do or no do not. So technically, there is something missing probably. You could find, if you were like a language lawyer, you could find something missing from this Python language reference. So it's not complete. But Ecmascript says, okay, here, this has everything, right? It also has, of course, it mentions the grammars, it mentions syntax, of course, too. It also mentions the meaning, right? So there's syntax operations. So how is something, a language so important as JavaScript defined? Well, they use different approaches. For example, they use something called abstract, let's say runtime semantics, algorithmic conventions. Like they define things like, like this far here. That's how they write things, like top level step, substep, 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 like we would use in Python or like we would write on a paper, right? Abstract ones, right? They define these blocks, things like that, basically. Again, so it takes a while to get used to this again, and usually you don't really care about this, right? It's only when there is an issue with your language, right? And then you have to look it up. That's why this actually is important. Basically, what we're talking today is eventually sometimes you'll run a situation that the program basically something doesn't quite right exactly. You're not sure if it works exactly the way it should be working, basically, right? So that could be an issue, basically. So, let me see here, 1 second. 1 second. We'll keep talking in a moment. Okay. All right. So, yeah. So, but let's see our materials. We have a bunch of materials we can still look through, right? So there's different ways of defining semantics, right? So again, let's remember again, reminder about Hoare logic, right? The way he did this using these logical rules. Again, I'm not going to go deeper into this today, right? But basically, by defining everything through rules. Again, it's a very tempting approach if you're a logician, right? Not very tempting if you're actually a somebody who actually wants to use a language. It's only if you want to reason about the language, right? So quite difficult, right? So again, real life semantics, that's where we are, right? This was 262 when I did these materials last year, right? This was the big spec, right? Again, the reference. Let's see also, let me add the C++ one, right? Reference implementation language standard. Language standard. Let me see if I can. So like C++ have a language. Yeah. Technically, the C++ standard is a paid. Yeah. If you can compile LaTeX, Yeah, let's see if they can give you a link. There you go. All right. Let's add that for language, right? Or maybe let me. Yeah, it's better. Okay, but let's look at our Ecmascript 262, right? So, what do you want to check? I saw overview, right? This is non-normative, so this sort of like still gives you just big picture overview, right? The web scripting, things like that, but gives you object prototype relations. It adds some extra things, but let's look at definitions, right? So implementation, right? Everything. It's like again, you in order to find the meaning of word is, you have to define what is means. So implementation approximated, right? You have to define it, right? It's just like you have to provide definitions. Type, set of data values, primitive value, right? So everything is defined exactly, right? String, what's this? What's a Boolean object? A Boolean type, a Boolean value, for example, right? True or false? Boolean object, right? Again, there's, you know, JavaScript is a huge, pretty huge language these days, right? For example, infinity and not a number, right? Again, right? Arbitrary specific number, right? Infinity, positive infinite number, right? There's also negative infinity, probably, I think, if I remember correctly. Or I guess not, I don't see it, right? Again, I haven't written, I mean, I write some JavaScript. I used to write a lot of JavaScript, like 10 years ago. Now it's been changed quite a bit, actually. Now, so syntactic lexical grammars, right? Let's see if we can find the grammar specification, right? Non-terminal symbols, that's all we learned from previous lectures, right? So, but I want to see if they actually mention this syntax, right? One off, right? Do they mention this grammar? Abstract. So, algorithm conventions, okay? So, abstract operations, basically, right? To facilitate these, some algorithms, basically, they call them in abstract format, basically, right? So, abstract operations here, type conversion, basically, right? So, yeah, so to primitive, order to primitive, they define this. To Boolean, right? They define what these things do, basically, right? And that's what you do in a real language implementation. How about syntax? I want to see if we can find the syntax. But one thing we have not covered yet is the meaning, which I think makes things harder, is scoping, right? In languages, we usually have scoping rules. What's scoping? Like scope of something, right? Tvērums in Latvian.
Scoping in terms for...
Like variables.
Yeah, for variables?
Yeah, for example, yeah.
Well, their access capability.
Yeah, so their lifetime, basically, yeah. Yeah, where they are available, basically, right?
They are private, then they are
Yeah.
in the class, public,
Yeah.
public
And
everywhere. If they are protected, then within the
yeah, that's as far as C++. But for example, in JavaScript, again, this is language we have not yet talked too much, right? I mean, some of you use this, right, already, but it has some weird scoping rules, right? Like sometimes you can start using it before the variable is available, right? It's kind of weird. Like they have some really some examples, especially older versions, right? So you write the variable, right? You basically define it later, and you start using immediately, right? Some weird, so scope analysis, right? Bound names again, but this, of course, this is it's extremely dry even here, right? This is pretty dry. Static semantics, right? Right. It is syntax error if bound names or formal parameters contain any duplicate elements. That's a good rule, right? I think almost every language will have this rule, right? What does it say? It means basically that if you have you cannot define two variables with the same name in the same scope, right? Static semantics, right? So contains expression, right? So no arguments returns a Boolean, right? So contains expression, right? Array binding, right? Let's see something else we can look at. Function definitions, right? For example, how do we define functions, right? And this is how you define a function. This is officially, you have binding and there's an identifier, there are formal parameters, there's function body, right? And there's also something, you know, potentially, you know, you get something out. That's a very rough overview, but of course you have a await keyword, yield keywords, there's things like that inside, right? So again, let's not go into JavaScript specification right now, but again, defining something as it seems obvious. Oh, what's a function, right? By now, I know it is, right? But different languages have different ways of what function is, what does actually, right? Same as, for example, class definitions, right? JavaScript technically is prototype-based language, at least that's how it started, right? So the class is sort of bolted on, right? It's not like C++ or Java, right? So, but of course everybody wants to use object-oriented programming language construction, so now it has a full class syntax as well, right? For example, also let's look at arrays, right? Let's look at arrays. Let's look at arrays in JavaScript, right? Let's see arrays. Where are my arrays? Oh my God, so many data structures. Index of collections, array objects. You see, so I like what they say. So basically, we all know what arrays are, right? But look at the JavaScript definition. It says exotic objects. Arrays are exotic objects. I like that name. Do you know why? Because in JavaScript, arrays are really not arrays. They're kind of basically like a dictionaries, basically, like we know in Python, basically, right? They just have numbers as keys, basically, right? But they sort of hide the complexity underneath, right?
What do they define as exotic objects?
So yeah, let's look what they say. Exotic objects, right? Exotic objects. I like that name. So basically, it's an object. Right, it's not an ordinary object. I like this name. It's an object. It's not a normal object, right? So arrays, right? So basically, underneath there's an object, right? Prototype object, right? But it has some extra things and extra limitations and extra, I'll call them methods, right? So extends, right? So different types. So let's see what kind of ones are there, right? These are essential methods. These are everybody has it, right? And where are exotic methods, right? Let's look at this here, right? In string array, right? Yeah. So array is very well known, but again, there's no separate array. It's like I said, it's built on object syntax, which is basically object again is something like dictionary in a Python, basically. And it's not, but this is not the only language. I believe Lua has this approach too, right? PHP also, by the way, right? I believe PHP also, at least originally, do not have arrays. They're all key value stores, basically. Why can we do this? Because of course, key 0, key 1, key 2, key 3, right? It looks like an array. It looks like an indexed array, but underneath actually it is actually a key value lookup. But okay, but so that's what I'm saying is, you have to specify these things, actually, how it works underneath if you're writing a language, right? So, very, 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 very difficult thing to do, actually. So, scope analysis, right? Labels, right? Contains labels, right? So, yeah. So that's a big picture overview. But let me go back to one of the slides from University of Arizona, right? So, semantics, right? So, we talked about variables, right? We can't have doubles, right? Functions, parameters. Again, let's see. So, name, again, the scope. Once you can declare something, you have to say how long is declaration valid, right? Is it global? Is it program? Is it file? Right? Again, so, how long and how to resolve the name, right? So, for example, here's an example. C uses block level scoping, right? You have blocks, right? JavaScript is usually function level scoping, at least the original JavaScript, right? So, again, very, very different. Right, so C++ here. C, but C++ also works, right? So of course, I here is in the scope, right? And this will be an error, right? You remember your previous course, right? This will be an error, right? Because there's no I in this block, right? In a way, I like this. It's easy to reason about. But look at, I think that shows JavaScript example, right? It doesn't show JavaScript example, right? But yeah. But JavaScript has a different way of doing this. So, study coping, again, maybe you already resolve these names, maybe you do this at the runtime. Again, this has to be declared, right? So, again, yeah, you can declare this. Also, dynamic scoping, you update, right? At runtime, again, let's not go into the details of the language right now. I don't want to, Just I'm showing you the problems we have to solve. What you have to define if you're writing your own specification, right? So also, how do you resolve function calls, right? By name, right? What do you do if the signatures don't match, right? Do you let signatures, right? Do you allow multiple functions by the same name but different signatures, right? In C++ we can do this, right? In Python we really can't, right? We can't write the same function with different signatures, right? We can't. I mean, we can, but it will overwrite, right? Yeah, we can. Python lets you do it, but it will overwrite, right? So again, the details itself are not, not essential, but here there are different interpretations, right? Different ways of resolving this, right? So all of this has to be spelled out, right? Again, so function resolution, assignment, again, the simplest thing ever, right? Assignment. So what does it mean? And the answer, of course, is it depends, right? Because, again, like this semantic of this equality, because it could be like in C++, it could be overloaded. It could do actually, it could launch a rocket launcher, right? But it could launch a spaceship. But here, right? Are you, what are these variables, right? Where is the value stored, right? And of course, are you copying or are you just providing a pointer reference, right? Is copy by value, copy by reference, right? How do you bind? How do you associate the values, right? Basically, right? So that's very, very crucial to define in your language, right? So all of this has to be specified. Assignment semantics. Yeah, index X, right? And you could write diagrams, right? Binding, location, value. You can use a box and circle diagram if you want, right? I don't know. Does Ecmascript? Let's see how does Ecmascript binding? Let's search for this binding. Binding pattern. Production binding list. Early errors. This is very hard. Binding identifier. That's yield, await, quality. Okay, value, an environment, right? No completion or approved completion. All right, so let me see if you can see the expressions. Statements. Oh, statements and declarations. Yeah, statements. Empty statement, expression statement. Okay, let constant, right? This tells you what you can do. All right, how you declare let and constant, right? And you combine things, right? Early errors, and a variable statement. You can also use variable statement, right? This is the old one, right? And you can use that one, right? Of course, maybe let's look at Lua language. It should be easier. Let's see, Lua language specification, right? It might be easier to look at, right? Maybe there is. Oh, you see, this is how I do it. Official definition is its reference manual. Keep things simple, right? So this is probably one of the easier languages to learn. Again, still very powerful scripting language used in many games and things like that, right? For game logic, right? Good language, to pick up just on a side, basically, right? So there's the English version. Actually, it's written by Brazilian, right? So let's see how they do it, right? So this should be simpler, right? Rio, right? So basic concepts, right? Values, types, right? Environments. It's just basically written like a novel, but basically tells you, right, what kind of method operations, like what's allowed, right? Garbage collection. What kind of garbage collection is there? Weak tables. Coroutines, right? Lexical conventions, like these are the keywords, right? So this is more syntax, of course. So notice this also covers the syntax. Variables, right? Variables are places to store values. I like the definition, right? Global variables, local variables, and table fields, right? So single name could donate the global variable, local variable, right? And this is how you define a variable, right? In Lua, right? Statements, right? Block is a list of statements which are executed sequentially, right? Also, you can do empty statements, right? Right. Yeah. So both function calls and assignments can start with an open parenthesis. So this is interesting. So A equals B plus C, and done, right? So grammar could see this is a problem, right, potentially, that this is A plus B plus C, right, and then do something, right? Or maybe this is called C print or I overwrite, right? So this is kind of part, so that's why you need to do it semicolons. That's why semicolons, often syntax says, you should do semicolons, right? So again, like this, yeah. So Lua is probably something the most readable reference manual. Actually, let me add this to our materials. I like this one here. So Lua, reference implementation, reference standard, language standard, reference implementation, and maybe here, here we are, and also reference manual. Language like Lua, only show reference. Yeah, 5.4, right? 5.4, yeah, manual. Let's see. Yeah, official definition, right? Again, if you're looking at the manual, check if it is actually, if it claims, of course, I could write a book and claim it's an official manual on Python, but of course it doesn't make it so, right? So, but here we trust that the people who run Lua org, they actually know what they're doing, right, basically. Okay, what else do we need to talk about? What you need to specify, right? So, another way which is actually decent is test suites, basically, right? So basically, it could be completely standalone, or it could be part of a bigger sort of like combined approach. But basically, you have test suites for your language, and basically you run those suites, right? And if they pass all the tests, hey, that's the language, right? It meets those specs. That's okay. It's all correct then, basically, right? That's when you're doing it. Again, so information. Also, of course, it's possible, right? There's no official specification. There's no reference implementation. So basically, you have your documentation, tutorials all together, and so this happens when you have some very niche language, or we call them domain-specific language for specific usage, right? What could be some examples? Well, let me see if we can some examples, right? Yeah. It's right. Example of such informal. Well, it claims MDN web docs. Well, yes and no. Of course, we do have the official spec. Yeah. Yeah. So this is interesting, right? So MDN, right? Of course, for Java web docs, of course, would be more friendlier, right? You don't want to read just compare these docs, right? Right. This is what everybody uses. This one, right? It's much friendlier to read, right? Now, technically, of course, you're supposed to, if you're writing your own interpreter or whatever for Ecmascript, of course, you're supposed to read this, but nobody really wants to do it, right? Unless you're in committee there, right? You look it up if there's no if something is not clear here, right? So pragmatic approaches, you use the best documentation there is, the friendliest one, right? And then you look up things as one need to know basis there. All right, so what else didn't we talk about yet? So binding, assignment, right? Yeah, and box. Again, so copy, right? Again, x equals y. Again, of course, this arrow is doing a lot of heavy lifting, right? Is it actually copy? What kind of copy is it, right? Is it actually a copy by value? This says value, so this actually looks like a copy, right? Actual real copy, not just a pointer to the data, right? So it's not necessarily true in our languages, right? So assignment, right? X equals x, right? Nothing happens, right? Just keeps overwriting, right? So there's something called left value and right value again, right? So again, these are of course makes sense. L value left, R value right. But of course, they also has some other meaning. These L value and right value, right? So R value is B plus C, A is L value, right? So in this particular case, assignment semantics, you define again. We could come up with something else, right? I mean, again, remember we could say is the rules of precedence, right? Syntax does not define this, right? I could say this is actually A should be B, and then we add C and do nothing. I mean, it's kind of stupid, right? But it would technically, we could define it like that, right? Or maybe we could do say A is actually B first, and then you add C later, all right? Okay. And this would be actually, if it's big step, that could happen if you don't declare it, right? If you do a small step, it would not, small step semantics, you don't skip this step, right? So pointer operations, again, this is all, you have to define like using these boxes here, right? Okay, what else I want to talk about? Semantics, right? So informal documentation, let's add Lua and MDN. So again, living standard, right? It's also possible that real semantics is a combination. You have this formal documentation. So technically, MDN, I mean JavaScript, right? Ecmascript, right? It goes together, right? Yeah. So living standard for HTML, right? So sometimes we have something called de facto standards. Basically, there is something dominant like Oracle SQL, right? On SQL, it's like there might be a standard, but you have to follow the market leaders, so everybody sort of follows what language specification is. So that's kind of interesting. Like in a web technologies, oftentimes now used to be that Microsoft with its Explorer defines some non-standard specifications, right? Now it's happening with Chrome, right? They're coming up. Google is sort of became, I'll call it, kind of evil, or maybe pretty much evil, right? And defines their own additions to the standards, right? Of course, they sit on a committee for Ecmascript, right? But they are free to do something extra on their market-leading browser, right? Like the one I'm using right now, right? So, okay, but usually, of course, there's combination. So, in the real world, again, we go back to the real world, why this is all important. Java has a formal specification, right? But you have a reference implementation, you have a test suite, so all of those. So formal methods are invaluable for our academic study, right? And you can get some insight, but they're extremely cumbersome, right? If you're doing commercial language or working anything in the real world, of course, this is not going to be very, how should I say, scalable, right? But sometimes you have formal definition, right? You can validate. You have extra safety, right, of validating, right? So tools, there are all kinds of tools for this. By the way, JetBrains has a language workbench, right? It lets you make your own language, basically. Let me see if it's still around, right? I checked last time. I checked it was there. I think it's a plugin, right? Yeah, create your own domain-specific language. Kind of cool, right? Again, reminder that if you're a student, JetBrains gives you, I believe, all of the cool things for free. I believe, right? Yeah. So you can write your own language. So this might be something cool, right? Try, right? You come up with your syntax, right? Right? And you basically, it will work, right? It's basically your own language, right? Right? Net R, right? So we'll make it general. It's kind of cool, right? So still around. What's the pricing for this one? That is free. I believe it's free. Just download. Is the price for this? Well, if you're Bosch, yeah, Waterloo, it's a very good university in Canada. McGill, yeah. So, very cool thing. So, what else? Yeah. There are also formal verification tools. These would be if you were actually, look at the materials, actually went through the trouble of making this writing up your language specification using these formal standards, right? And then you can check, right? You can check whether a language actually passes all. It's kind of like testing, really, but it's formal verification, right? So, what else? There's also tools for analyzing languages, right? Right. Testing tools, right? Different tooling, right? And spin, model checking, right? So if you were making your own language, you define what the need is. Basically, why would you write this first, right? Again, some ideas what you would what kind of domain you're going to operate, and of course come up with the language features, right? You're going to have loops, most likely. You're going to have assignment, most likely, right? You're going to have if statements, yes. And then, of course, you do some constraints, some domain-specific constraints, right? And then you have to decide whether it's going to be external language, right? Its own parser, compiler, interpreter, or maybe, right, embedded ASL, meaning it's basically kind of inherit something from an existing language, right? Then you define a syntax, and then you define the semantics, right? Operational semantics, which we talked today, the notional, maybe axiomatic, right? And then technically we have to check, right? Again, if you're writing complete language from scratch, you have to do this formal verification. Again, optional, but highly recommended, right? Because possibly your language has a big flaw, right? Your loops don't work properly, right? Or maybe the thing is sometimes it works, but it doesn't work quite like you intended, right? It's kind of like a bug, basically, right? And implement, right, you have to, well, again, you might not have to write your own compiler, you can just transform it, transpile it to some other language, right? And of course test, and well, then you have to start documentation, right? Right, performance, right, so kind of cool. I also mentioned something, whether Gödel's incompleteness theorem applies to this, but this doesn't really, even though it's very important for programming in general, but for language design it's not that crucial actually, right? We don't really need to we don't need to do this, not to worry about it too much here, right? So, but one thing we have to remember that we can't really there's a halting problem. You might have heard of halting problem, right? That you cannot write a program that will answer the question whether the program will halt or run forever, right? In the same language, basically, right? So, yeah. So some things you can't really verify. That's what I want to mention. So, a couple good books on this subject. Types of Programming Language. This one is quite excellent. Let me see if I can find a link to this one here. I think I had it. Let's see. I don't know if we have it in our library. I believe Amazon. Oh, University of Pennsylvania. Right, this one here. Yeah, this one here. Order from MIT. It's from, let's see how much does MIT wants for this book. 95 euros, no dollars, sorry. But shipping is extra probably. Alright. Let me add the link to this one. Yeah, let me add this. This is a good one. I wish we had this here. Book. Types and yeah, this is it. Yeah, correct link. Yeah. Image. Let's see. No, not from Amazon. I'll take it from here. Hot link from here. I like living dangerously. Hopefully, MIT or no, University of Pennsylvania is not gonna. Yeah, there we go. Yeah, hot link. All right. They're not gonna ban me on that one. All right. So advanced topics, right? So formal semantics, right? So this is again, if you really want to get into this, right? Formal semantics again does not. If you want to fall asleep, might be a good approach. Let's see. Is actually. No, this looks like somebody's it's not actually the full book, right? Not an official site, intranet, somewhere in Brazil, right? So that's not the right book. Again, you have to be careful when you are looking at. Looks like somebody has a full book here, right? Not officially, I'm not sure. Probably not legal, right? Yeah, probably this is the site you want, right? You didn't see it from me here, right? But this is actually but it's actually quite old, right? $80 for book written in '93. I don't know, right? So good book still, but right, for proving things. But this might be the official site. Right, let me add the official site here. All right. So classical text. Right. Oh, it gives you this one, Parker, but that's not the guy. I will give the MIT link. Yeah, all right. All right, I think that actually is going to be enough for today, right? So, what did we learn? We learned there's many different ways of defining semantics. For you, the one you care most is the actual reference implementation, the documentation, canonical reference documentation, not just any documentation, not just random blog posts, right? Tests would be good to have. And again, there is a way of formally specifying in very minute detail what the language does. That's usually just done for like a full verification, which you usually don't sort of as a user, right? You usually don't worry about this too much. But if you're actually this language designer, you will want to go through that as well. All right. So let's see what we do next in next lecture. If I have forgotten already, all right. I think we'll start finally. Yeah, finally, we'll get to some programming, right? Yay! We'll get to functional programming, finally. Yeah. So we'll finally actually learn a new language. So we'll look at closure on start learning. I think we'll have how many lectures we can have? 1, 2, 3. Yeah, we have 3 lectures. Yeah, so pretty good. I think enough to pick up basics, right? Not pragmatics. Again, style. You will not pick up the full style, but you'll get the idea. And maybe break your brain a little bit. Maybe twist your brain a little bit. It's a good language to learn in that regard. So, all right. Thank you, everyone. And I'll see you on Thursday, or maybe some of you will see you today downstairs, right?